All right, let's get into it. Have you ever stopped to wonder what kind of complex machinery is actually humming away behind those super slick, fast apps you use every single day? Well, today, we're going to peel back the layers. We're deconstructing the modern tech stack from a senior engineer's point of view.
You know the feeling. You tap a button and the screen just updates. Instantly. It feels like magic, doesn't it? But it's not magic. It's just really, really good engineering. So the big question we're tackling is this. What is that invisible architecture, that hidden scaffolding, that makes the whole experience so seamless? We're going to take a journey behind the screen. So our journey starts right where every user's does, the front end. This is the user-facing layer, the part of the app that you can actually see, touch, and interact with. But trust me, it's just the tip of the iceberg. At the very heart of this layer, you'll almost always find a powerful framework, like Angular. Its entire job is to build that user interface, the UI. Think of Angular as the director of a Broadway show. It's controlling everything you see, how the actors, or buttons, react when you interact with them, and how all the data is displayed on stage. It's all about making sure the performance is smooth and totally responsive.
And the power of a modern UI is honestly staggering. We're talking about the ability to handle over 10,000 real-time events. Things like status updates, new messages, you name it, all without a single stutter or freeze. Now that is the kind of invisible engineering that separates a truly great app from a frustrating one.
Okay, so your click on the screen needs to talk to the brains of the operation, right? But here's the thing, it doesn't go there directly. First, it has to pass through this critical middle layer. I like to call it the smart gateway, which is absolutely essential for the system's resilience and speed.
And for this super important role, engineers turn to technologies like Node.js with the Express framework. This is our middleware. It acts as this really clever and efficient go-between, sitting right between the user interface you see and all the heavy-duty processing that's about to happen in the back end.
So what does this gateway actually do? Well, it is a master multitasker. First, it acts as a security guard, checking your digital ID, what's called a JWT or JSON Web Token, to make sure you're allowed in. It's also a speed booster, storing or caching frequently used data, so it doesn't have to bother the backend every single time. And finally, it's a translator, taking messy, complex data and simplifying it into a clean, easy-to-use format for the UI. In short, this one layer makes the entire system more secure, way faster, and a whole lot more efficient.
All right, our request has been verified, it's been optimized. Now it's time to enter the real core of our system, the back-end engine room. This is where all the complex logic and the serious heavy lifting of data processing actually happens. Now, to understand modern backends, we really need to talk about architecture. See, in the past, a lot of systems were what's called a monolith, one gigantic, tangled-up codebase. If you wanted to make one tiny change, you had to redeploy the whole thing. The modern approach? Microservices. This means breaking the application into lots of small, independent services that can be updated separately. It just makes the whole system way more flexible and a lot more resilient.
Here's a great way to think about it. Imagine a restaurant kitchen. A monolith is like one single chef trying to cook a huge 3-course meal all by themselves. If they mess up one little thing, the whole meal is at risk. It's slow, it's risky. But microservices, that's like a full kitchen staff. You've got specialists for appetizers, for the main course, for desserts. They all work in parallel, they're much faster, and hey, if one station has a problem, the rest of the kitchen just keeps on cooking.
And in our microservices kitchen, we've got some serious powerhouse tools. Those specialist chefs, they're often built using a language like Scala, which is just fantastic for handling complex logic and crunching massive amounts of data. And to get the ingredients, the data, between all these chefs, quickly and reliably, we use something called Kafka. Just think of it like a super fast conveyor belt, streaming information between all the different microservices.
Okay, so we've seen all the individual layers, right? We have the front end, the middleware gateway, and that back-end engine room. So now, let's put it all together and trace the full journey of one single request from the very beginning to the very end.
Okay, so let's follow a single click. Ready? 1. You interact with the Angular UI. 2. Your request instantly hits that Node.js gateway for a security check. 3. It needs fresh data, so it gets zipped through the Kafka conveyor belt to a very specific Scala microservice. 4. That service does its complex work and sends back a response. And 5. The gateway intercepts that response, tidies it all up, and delivers a perfect piece of data right back to your screen. And this all happens in the blink of an eye.
And this quote from the source material just perfectly sums up why this architecture is so effective. Each part has a very specialized job. Scala is laser-focused on the heavy-duty computation, while Node.js is an expert at managing all that web traffic and just keeping the user's experience incredibly snappy and responsive. It's really the best of both worlds.
So does all this architectural elegance actually pay off?
Oh yeah, absolutely. In one case, this exact design led to a 30% reduction in load time. Now that is a difference you can actually feel, turning what could be a frustrating wait into a seamless experience.
Okay, so we've seen all the intricate layers of the machine. But what about the mechanic, the person building and maintaining all this? Well, in a system this complex, the role of a senior engineer goes way, way beyond just writing code.
You see, a senior engineer's real value lies in three key areas: leadership, a deep sense of ownership, and a relentless focus on the long-term health of the entire system. They're not just building one feature, they are building a foundation that will last.
And that means they're not just sitting there coding all day, they're shaping the entire process. They drive those big architectural decisions, they own the automated deployment pipelines, often called CI/CD, and they mentor junior engineers, lifting up the entire team. And critically, they're always working to reduce what we call technical debt, all those messy shortcuts that can slow down progress later, to make sure the system can grow and evolve for years to come.
And here is the real-world impact of that ownership. By taking charge of the deployment process, one senior engineer was able to improve deployment speed by 40%. That means new features and critical fixes get to users faster and more reliably, which is just a massive win for everyone.
So we end with this question, because it really gets to the heart of the mindset. What is the ultimate goal? Is it just about shipping the next feature as fast as you possibly can? Or is it about building a healthy, scalable, and maintainable system that is capable of delivering features reliably for years and years to come? That strategic, long-term thinking, that is the true mark of a senior engineer.